What is data cleaning? Data cleaning is process of fixing or removing incorrect, corrupted, incorrectly formatted, or duplicate or incomplete data within a data set. When combining multiple data sources, there are many opportunities for data to be duplicated or mislabeled. If data is incorrect, outcomes and algorithms are unreliable. Even though they may look correct, there is no one absolute way to prescribe the exact steps in the data cleaning process because the processes will vary from data set to data set. But it is crucial to establish a template for your data cleaning process so you know you are doing it right way every time. So within the data warehousing field, data cleansing is typically applied when several databases are merged. Records referring to the same entity or often represented in different formats in different data sets. Thus, duplicate records will appear in the merged database. The issue is to identify and eliminate these duplicates. The problem is known as the merge purge problem. So, in the literature, instances of this problems are referred to as record linkage, semantic integration, instance identification, or object identity problem. There are a variety of methods proposed to address this issue. Knowledge bases, regular expression matches, and user-defined constraints, and others. Data is deemed unclean for many different reasons. Various techniques have been developed to tackle the problem of data cleansing. Largely, data cleansing is an interactive approach, as different sets of data have different rules determining the validity of data. Many systems allow users to specify rules and transformation needed to clean the data. For example, Raman and Hellström. They have proposed the use of interactive spreadsheets to allow users to perform transformation based on user-defined constraints in 2001. So this allows user to specify rules and conditions on a SQL-like interface, where they propose the definition of a reference pattern for record using fuzzy algorithms to match existing ones to the references. So in data cleansing is the process of eliminating the errors and the inconsistency in the data, hence solving the object identity problem. The data cleansing problem as much problem and they propose the basic stored neighborhood method to solve it. Data cleansing is basically much more than simply updating a record with the good data. Although data cleansing can take many forms, the current marketplace and technologies for data cleansing are heavily focused on customer list. A good description and design of a framework for assisted data cleansing within the merge purge problem is also available. Most industrial data cleansing tools that exist today addresses the duplicate detection problem. By comparison, there are few data cleansing tools available from past 5 to 6 years, which probably help you to clean your data. So we have taken the overview, but now we will deeply understand what exactly the data cleansing. It's a process of identifying, deleting, or replacing inconsistent or incorrect information from the database. This technique ensures high quality of processed data and minimize the risk of wrong or inaccurate conclusions. As such, it is the foundational part of data science. The standard data cleansing process consists of following stages. Those are importing data, merging data sets, rebuilding missing data, standardization, normalization, deduplication, verification and enrichment, and exporting data. It can be easily visualized as a cycle move. Everyone intuitively understands the premise of data cleansing. It is pretty straightforward idea. So in order to get the best possible results out of your data, you need to make sure it's clean. But what is clean? Data? Clean data is a piece of information basically that meets the requirement of quality data and hence will contribute to uncovering valuable business insights. Fortunately, there is a consensus as to what can be considered clean quality data. Let's briefly have a look into what properties quality data consist. It could be accurate. So accuracy is very important in cleansing the data. So this accuracy is measured by a degree of compatibility between the data in question and outside data sources. It is our true value or a golden standard. After accuracy, completeness degree to which all required measures are known. Then come consistency. It relates to the degree of compatibility of databases across the whole system. Important step is relevancy. So the degree of usefulness of data, determining how closely a piece of information is related to an issue you are researching on. Then validity, here, the degree of which data in question conforms to defined rules or constraints. Example, information containing dates should fall within a specific numerical range. Timeliness. So most data loses relevance pretty quickly. So this parameter is related to how fresh and up to date a piece of information is. Uniformity, related to the consistency of units of measures in all systems. Example, data sets coming from the US and Germany might use different units of weight, that is pounds versus kilo. So why does data cleaning matter so much? So data analytics is a complex, time-consuming, expensive effort. If you're working with large sets of data, chances are there are significant business consequences involved, like deciding where to allocate your funds best or how to reach peak productivity. That's why it's imperative to minimize the risk. How do you do that? You do that with data cleaning, with proper data cleaning procedures. One can't be sure if their data analytics results will provide real insights. But to demonstrate the gravity of the situation, let's analyze two data analysis scenarios, one with data cleaning and other without. So first you need to figure out what analysis you will be running and what are your downstream needs. What question do you want to answer or problems do you want to solve? Before that, take a good look at your data and get an idea what is relevant, what you want, you need, and filter out data and observations that aren't relevant to your downstream needs. If you're doing an analysis of SUV owners, for example, yeah, but your data set contains data of sedan owners. So this information is completely stands irrelevant to your needs, would only skew your result. You should also consider removing things like to take a good look at your data and get an idea of what is relevant and what you may not need. Filter out data or observations that aren't relevant to your downstream needs. If you are doing an analysis of SUV owners, for example, but your data set contains data on sedan owners, this information stands completely irrelevant to your needs and would only skew your result. You should also consider removing things like hashtags, URL, emojis, etc., unless they are necessarily a part of your analysis. Deduplicate your data. So if you're collecting data from multiple sources and multiple departments, use scrap data for analysis. Or have received multiple surveys or client responses, you will often end up with data duplicates. Duplicate records slow down analysis and require more storage. Even more importantly, however, if you train a machine learning model on a data set with duplicate results, the model will likely give more weight to the duplicates depending on how many times they have been duplicated. So they need to be removed or for well balanced results. Even simplistic data cleaning tools can be helpful to deduplicate your data because duplicate records are easy for AI programs to recognize. Fix structural errors. Structural errors include things like misspellings, incongruent naming, conventions. Fix structural errors. Structural errors include things like misspellings, incongruent naming, conventions, improper capitalization, incorrect word use, etc. These can affect analysis because while they may be obvious to humans, most machine learning application wouldn't recognize the mistakes as your analysis would be inappropriate. For example, if you're running an analysis on different data sets, one with a woman column and another with a female column, you would have to standardize the title. Similarly, things like dates, addresses, phone numbers, etc., need to be standardized so that computers can understand them. Deal with missing data. Scan your data or run it through a cleaning program to locate missing cells, blank space in text, unanswered survey responses, etc. This could be due to incomplete data or human error. You need to determine whether everything connected to this missing data, an entire column or row, a whole survey, etc., should be completely discarded. Individual cells entered manually or left as it is. So, in this case, the best course of action to deal with missing data will depend on the analysis you want to do and how you plan to pre process your data. Sometimes you can even restructure your data so the missing values won't affect your analysis. Filter out data outliers. Outliers are data points that fall far outside of the norm and may skew your analysis too far in a certain direction. For example, if you are averaging a class's test score and one student refuses to answer any of the question, his or her 0% would have a big impact on the overall average. In this case, you should consider deleting this data point altogether. This may give results that are actually much closer to the average. However, just because a number is much smaller or larger than the numbers you are analyzing doesn't mean the ultimate analysis will be inaccurate. Just because an outlier exists doesn't mean that it should be considered. You'll have to consider what kind of analysis you are running and what effect removing or keeping an outlier will have on your results. Validate your data. Data validation is the final data cleaning technique used to authenticate your data and confirm that it's high quality, consistent, and properly formatted for downstream processes. So, do you have enough data for your needs? Is it uniformly formatted in a design or language that your analysis tool can work with? Does your clean data immediately prove or disapprove your theory before analysis? So validate that your data is regularly structured and sufficiently clean for your needs. Cross-check corresponding data points and make sure nothing is missing or inaccurate. Machine learning and AI tools can be used to verify that your data is valid and ready to be put to use. And once you have gone through the proper data cleaning steps, you can use data wrangling techniques and tools to help automate the process. So data cleaning tips basically here are to create the right processes and use it consistently. Set up a data cleaning process that right for your data, your needs, and tools you'll use for analysis. This is an iterative process. So once you have your specific steps and techniques in place, you'll need to follow them religiously for all subsequent data and analysis. It is very important to remember that although data cleaning may be tedious, it's absolutely vital to your downstream processes. If you don't start with clean data, you will undoubtedly regret in the future when your analysis produce garbage results. Trust me. Then you have to use tools. There are a number of helpful data cleaning tools which can put to use to help the process from free and basic to advanced and machine learning augmented. Do some research and find out what data cleaning tools are best for you. If basically you know how to code, you can build models for your specific needs. But there are great tools even for non-coders. Now pay attention to errors and track when dirty data comes from. So this is a very good cleaning technique you need to use on data from different sources. This will save huge amount of time and make your data even cleaner, especially when integrating with analysis tool to use regularly. So now I hope everyone has got how important data cleaning is. So it's clear that data cleaning is necessary. So remember to keep your processes consistent and don't cut corners on data cleaning. You will end up with accurate, real world, immediately actionable results. So we end the chapter here. So in the conclusion, we have to understand data entry, data sanitization, and cleaning are a critical components of effective data management. So by prioritizing accuracy, reliability, and security, organization can unlock the full potential of their data and drive success in today's data-driven world. So by incorporating data cleaning and sanitization into their data management processes, organizations can enhance the reliability and, most importantly, the trustworthiness of their data. This, in turn, leads to more accurate insights, better decision making, and improved business outcome. Here, on a good note, I end. Thank you for your time.